Hello everyone and welcome to this tutorial where we are going to build a simple compose multi-platform clean architecture notes app. So in this tutorial we are going to focus about clean architecture, and so are not going to focus like on building beautiful UIs or having functionalities or real data sources, but the main focus is the architecture of the project and using the clean architecture. So let's start by creating a new project. So to make it easy, I prefer using KMP, Kotlin Multiplatform Wizard, kmp.jetbrains.com, and you can create a new project easily here. So just specify the project name, the project ID, and the targets. You can select Android, iOS, desktop, and there is web as well. So I have this project here, so I can just run it on Android or iOS or desktop. Let's run it and see. So for running the project, you can go for Gradle here, open tasks and compose desktop and run, or just simply in the terminal Gradle run and hit command enter, and it's going to run on desktop. Okay, here we go. So we have this beautiful compose multi-platform desktop application, and yeah, with a button and an image. So let's get started. We are going to run on desktop mostly because it's faster and easier. We don't need an emulator or something. Okay, so we are going to build like a simple notes app. We will have two screens, a screen for listing all the nodes and a screen for adding nodes, and we'll use it for editing notes as well. So we have this project, and you can go here and see the app. So we will need navigation. Let's start by adding Voyager to our project. So I prefer using Voyager for handling navigation because it's a lot simple. You don't need a lot of time to set up Voyager. Okay, so after adding Voyager to our libs, I sync the project, and I will add it to build the .gradle in the common main. So let's add here libs.voyager, and let's sync the project. Okay, now we don't need this greeting class. I will remove it, and I will go to app. I will change material here with material 3. Like, are not going to make a lot of customization in the UI, but material 3 projects looks better. So I will remove everything in the app. Okay, so I'll change it with the material 3 material theme, and now let's add the navigator here from Voyager, and then we can set our screen. So now let's create our screens. So the first feature is listing all the nodes, which is the home screen. So I will create a new directory named home, and I will create a directory inside the home called UI, and our presentation, but I prefer UI because it's just simpler, and I'll call it home screen. Let's create an object. Okay, and we will extend from Voyager screen. Now we need to override the content method here and mark it as a composable function. And yeah, now we have this screen ready. I'll add scaffold, with a modifier, and let's add fill max height or fill max size, and safe drawing padding for screen insets or window insets. Okay, now here we should have the nodes, so let's keep it like that for now. And let's add top bar, and okay, let's add top bar here in the title. Let's refactor this, and for the title I'll just add the simple text, notes app, and I'll add navigation icon, or okay, not navigation icon but actions. Let's opt in here, and for the action I'll add a little icon button for adding new nodes. So here we will navigate to add node screen, and let's use an icon here, icons dot rounded, maybe add content description, add note. So here we have this top up bar, this simple top up bar with a title and an add note button, and here we are going to list our notes. Okay, so this is just for the home screen for now, and we will add the home screen as our default screen in the navigator. So before starting now, let's just understand a few things. So in clean architecture, we have the domain. Okay, sorry. I have the domain, and we have the data, and we have the UI. So we have these three layers, or presentation. You can call it whatever you want. It's just names after all, but yeah, we have these three layers, and we have the UI. So we have some rules. The UI is using the domain, and the data is using the domain as well. So these are the rules, and we can't like use the data inside the UI, or use the UI inside the data, or use the data or the UI inside the domain. So the domain is our abstract module, you can say, but or for now it's just a single module, but we can even go further and have like each one of these a single module, you know. But in general, the domain needs to be abstract and doesn't know about other parts of our project. So yeah. So in the domain, mostly we'll have a model. So for example, for our case, we have a node, and we have a repository, which is an abstraction. So an interface, which is in this case, so here we can say this node model or something. And here, yeah, node repository. So these are the parts of the domain. And in the UI, we will have the screen. So we can type here, we have the screen, and you have the state and the event, and we have the view model. So let's make it like that. And so in this case, we will have the node screen, and the node screen, the node state, and the node event, and the node view model. So that's what we are going to have here in the UI layer. And in the data layer, we will have the repository implementation, and we'll have the data source, or multiple data sources, and we'll have DTO or many maybe. So it depends, but each data source is going to have a DTO, which is a data transfer object. So for example, if we have a remote data source and a local data source, each data source is going to have a DTO. So yeah, that's the data. And now that's what we are going to have, and that's what we are going to build. So each feature is going to look like that. So we will have like multiple features. So here, all of this is inside a big feature of a node. But let's say that we have users, for example, and we will have a profile or anything else. So we'll need to create like all of these things again for the profile and make it like separate from the node feature. So we'll have each feature totally separated, and then when maintaining the project, so now I'm just maintaining the node feature, I only need to look into these parts. Mostly it's going to be like just a repository, a model, a repository implementation, a screen. Even for like if we have 1000 feature, if you go to the node feature, that's all you are going to have there. So that's how clean architecture makes our life easier. So it's make the project more scalable and readable and extendable. So you can maintain all features even if you have hundreds of features. Okay, now let's get started. So let's create, so we said that we have the node feature. So let's create the node package here. It can be a separate module, but that's I think another case for now. Let's keep it for another video about the multi-module architecture. But for now, let's keep it simple in only a single module. So now we have this node here. I'll create a new directory or new package called UI. I will disable this so I can create the data and domain packages. So here we go. So here we have the data and the domain. I can enable this again now. Okay. Now the first thing is the domain, because it's abstract, and as we said, so it doesn't need data or UI. So we can start with it because we will need it in the data or the UI. So that's how we work in clean architecture. So we start defining the repository and the model in the domain layer. Then we can choose whatever we want if we have our designs ready maybe, and so we can start with the UIs and the states and all of that, and keep the data layer and wait until the backend is ready. And if it's the opposite, if the design is not ready yet and we have the APIs ready or whatever data sources, so we can start with the data layer and until the designs are ready. So we can choose, it's not a big problem. So we don't need to have everything ready to start. So I can start with the UI or the data. It depends on the case. But even if both the design is ready or the API is ready, so you can choose whatever you want. Or you can have two separate teams, a team working on the data layer and a team working on the UI layer maybe. But in all of these cases, we need to start with the domain layer. So here we will have our model, a node model, which is a data class. So let's say we'll have an ID of type string, and we'll have a title string as well, and a description of a type string. So that's good for a node model. Now let's define our node repository, which is an interface containing all our methods. Repository. So let's have like a basic CRUD, like a suspend function, insert, node and accepts a node model. Let's make it returns a result of a type node model. So this result is a Kotlin class, which is for handling success or failure cases. So we can have, if it is success, we will receive a node model, and if it is a failure, we will receive the throwable exception. So also I'm returning the node model here because mostly when inserting something new, especially to an API, we don't have the ID. Mostly the ID is going to be generated by the database or the backend or whatever. So we are going to get the item back with the ID. So maybe we need it for something. And we will have update node, which is a node model, and it's going to return a result of a node model. And we will have so we'll have get node or get by ID, and the same. So result of type node model. We can remove node here because we are already in the node repository. Let's add get all and result a list of a node model, and finally a delete button, a delete method to delete a node. So we can just return unit here. We don't need the node anyway. And yeah, that's it. That's our node repository, and done. We have the domain layer now. Congratulations. So we can have it in green or something. Okay, so now we have our domain layer is ready. So we can start by defining our UI layer or data layer. So for our case here, let's start with the UI layer. So of course now we are going, okay, so let's make it clear. We are talking about the screen where we are going to add or edit the node. So maybe if you want to make it more separate, let's just remove it from here. So we can just have another feature for add node or edit node or something like that, or we can just have it here in the UI. So if you are, for example, working on a multi-platform project, but you are not using Compose Multiplatform maybe, and you are just sharing the data and domain layer, so in that case your shared module is going to look like that, with just the data and the domain. You are not going to have UI here, and you will have a specific UI for Android and iOS or whatever. So it depends. So the UI layer can be somewhere else. It's not, we are talking specifically for Kotlin multi-platform, but for our case we are using Compose multi-platform, and we are sharing everything anyway. So here in the UI we'll create a new screen. Let's call it add node, and add node screen. So let's make it private screen content, because we are going to use Voyager object, add node screen and Voyager screen, and we have content here. So let's add a scaffold and add node screen content. So in the scaffold, let's add a modifier to fill max size and the safe drawing padding. Okay, so now we have this add node screen content. We don't have any states yet or events or whatever. So let's create our state, new data class, and let's call it add node state, which is a state representing so this is the state of our screen. So this state is going to decide how what is the state of the screen. So we need to have everything related to our screen here. So for this one, we have an add node screen. So basically we have a node, that's it. So we can type node or node model for type node model, and yeah, we have is loading and is success and is failure. You can decide, of course, you can have a message here, failure message. You can have like a generic data class wrapping all of these three. You can do it whatever you want, but yeah, there is a lot of approaches for this state here, especially for the loading and success and failure. So that's basically our add node screen, and let's add the add node event, which is a sealed interface. So here we can decide. So we will have I think we'll have the submit event, which can be data object called submit, or maybe add node, and yeah, that's it, I guess. I think I will change it to a data class, and we'll send the node here, because I'm going to save the node in the UI, so for the submission, because there is so it's just for the text field, because like there is some issues for the text field if you don't save the state in the UI. So now here let's get started with just a simple UI. So we can have a column with a modifier, a fill max size, and maybe padding of 20 dp, and let's have alignment start and arrangement of, let's say, spaced by maybe 18 dp. And now we will have two text fields. So let's define the states first. So we'll have var title by remember mutable state of, and string, an empty string. Let's import all of these getters and setters, and now the description, and by remember mutable state of an empty string. And here we go. Now this is our title, and on value change title equal it. We can have a label as well. Let's have a modifier first. So let's make it fill max width, and let's have a label with a text saying maybe title. Okay, so let's copy paste this for the description, and yeah, that's the text field. And now let's have a button on click, and with the text here saying add node. So just a simple UI to so to make something complete, but yeah, it doesn't mean to look beautiful, you know. And here what we will have, so we'll have the state, the add node state, and the on event, which is lambda receiving the add node event. And so what we are going to do is to pass the loading state to the button, so enabled here. So okay, I'll just add a simple if else. So if the state is loading, I'll add a circular progress indicator, and else the button. So you can have, of course, something a lot better than that, maybe a button with a loading state or whatever. And the on click here, we will have the node model here, of course. The on click will have the add node event dot add node, which contains the node model. We'll have it just a random ID here, because this is not the ID that we are going to use. And we'll have the title and the description, and yeah, so that's how we are going to do this. Let's make it better. Let's make it like that. Okay. Okay, it's a lot better, right? It's a lot better now. So yeah, that's it. That's how we are going to use our state and our event in the UI. So of course, we are trying to make sure that we don't pass the view model to the components to make them more generic and reusable. Now let's create a new class for add node view model. Okay, so we are using Voyager, and in Voyager there is something called screen model, which is a view model actually. So we can use it, which give us a coroutine scope and a state. Oh well, we can define our state, but yeah, it gives us a coroutine scope. So here let's have a private val is for our state, which is mutable state flow of default value and node state. Okay, let's have some default values here. So this is false, and false. And here let's create just an empty node. So we can just have an empty node here. Okay, so we can use this. So here we have this our state, and let's have the immutable state. So to state flow or as state flow. Okay, now let's add on event method, which so here we are going to handle our events, and then we'll have the when, and let's add all the cases, which is a single one here. Add node, so I always prefer having methods for each event to make it easier and more readable than having the implementation of each event here. So the add node, which will receive a node, an event of type add node. So here we will handle adding a new node. So of course in the add node view model we will need a repository, and so let's have a so I'll need to create a new package here for di. We will make di manual here, but yeah, for your project you should use something like Coin, for example, which support multi-platform. But yeah, for making things simpler, I'll make it manual. So let's keep it here until we create the repository implementation. So in the add node view model we will have a repository. So let's add the private val node repository, and then okay, so after adding a node, let's check let's check if the state is loading. So if it is loading, we're not going to do anything, just return. And if it's not, we will change it to loading. So save state.update it copy is loading equal true, and let's open our coroutine scope, and so let's go to our node repository and let's insert the node that we have in the event, and now we are receiving a result of a node model. So this result we can have like on success here, and on failure, which makes our code a lot better and more readable. So in the on success, let's have this here, and we'll have the is loading false and is success true. And so the same in the on failure, but we'll have is failure set to true. So yeah, that's our add node function. And then yeah, you can add a new events the same way. So having a new event here, and add the case and add the method for that event. So yeah, that's how we create our add node model. And here in the screen we'll have val view model equal remember screen model. So that's how it's done in Voyager. We are not going to pass the repository for now, but we'll do it later after defining the repository implementation in the data layer. So so here we will have a state val state by view model dot state dot collect as state. So this collect as state is for changing the state flow to a state. You can use it to with state flows. And here, so we'll have the state equal state, and the on event which is going to be equal the view model on event. And yeah, that's it. So we have now our add node screen. Let's make the link here in the home screen. So let's define the navigator equal local navigator current or throw. Okay, I'm not in the composable, sorry. So let's add it here, and then on click, if we click the add button, I'll push a new screen, which is the add node screen. Okay, that's good. And okay, now it looks good in the UI layer here, except for this. Of course, we'll fix it after defining the data layer. Here of course, if you have something like on, we are not going to have this issue, but yeah, we are doing it manually. We can go here and have something like let's say object node module and val node repository of type node repository by lazy, and let's say let's put null here and make none. Okay, let's make something better. Let's how to do and not implemented yet. Okay, that's better. And then we can pass this to the add view model screen, so we can have this here. Okay, let's pass it from the screen, and node module.node repository. Okay, we are good now. But of course, like that's just if we're going to do dependency injection manually, but again, are not going to need it. Use something like coin and you're fine. Okay, so now our UI layer is done. So we can jump into the data layer. So we have our state, our screen, our event, our view model. Everything is ready. So, and we can work, actually we can just work on the UI layer and do everything, but you don't need the data layer at all. So that's how it works. That's how we have this separation here, and we have the domain layer in the middle. So that's why. So you can work on the UI without anything implemented in the data. You can work on the UI without deciding if you are going to work with a local data source, a remote data source, both of them, doesn't matter. So we have our model, our repository in the domain, and we can work on the UI. And the opposite is correct. Of course, we can work on the data layer without having the design or whatever. So yeah, that's something that makes it really good to work with clean architecture and gives you more freedom and more options. So in the data layer, we will have we'll have a class which is the node repository implementation, which is going to implement the node repository interface. And let's add all the methods here. Okay, that's good. Okay, now I prefer to add new directory here for so for the data source, let's say here, for example, local data source, and let's add another one for the repository. So here we will have a class for our local data source, which is going to be fake here. Actually, it's not even local. It's local, but it's in memory. So we will handle the nodes here in memory. We'll have a val of node list equal mutable list of okay, node DTO, which is not defined yet. So let's have a node DTO here. With an ID and let's say title and the description. So here let's, so in most of the cases you're not going to have it like that. So you will have a more complex data structure. So the importance of the DTO here is decoupling and if I change something here, for example, if I change this to int, for example, or whatever, this is not going to affect my UI or my domain or whatever. So I just need to handle this changements in the data layer. And also I can have multiple DTOs with different data structures, and I'm going to map all of them to the node model. So here, let's say that we have so we have our model, and then we have like this here, and you have this here. So these ones are DTOs. Let's zoom in. So you have like a DTO number 1, a DTO number 2, and a DTO number 3. Maybe this is for our backend, and this one for our remote data or local database, and the third one for another backend. Maybe we have 2 different databases in the backend or whatever. So now what we are going to do is to map each one of these to our model here, so which is going to make it really easy. And like our UI doesn't care about having multiple DTOs, because we are going to use the model anyway in the UI. So this is not going to affect the other layers. It's only in the data layer, and we need to handle it there. That's it. So that's why we have the DTOs, but in this example we only have one. But yeah, the real importance of it is when we have multiple DTOs. So yeah, we can even, maybe in this case we have a single one, but maybe tomorrow, maybe next week, maybe next month, we will add other DTOs, and you will need it. And also maybe the structure of the data that it is returned by the backend, but you don't like it. So for example, let's say we have like a created at or whatever, and it is like that in the backend, and you need to make it camel case. Of course there is some annotations, but I mean like you can have the structure of the data that works with you, and that matches you better. So yeah, there is a lot of advantages of having these DTOs. So now here we will have let's add these different methods there. I'm going to just copy paste it here for make it faster. And of course we are not going to have the node model here. We'll have a node DTO, of course, node DTO and node DTO. And so here we're not going to have the result. And yeah, that's it. Okay, so let's define these methods here. And so for inserting, we are going to simply let's remove this, don't need it. Maybe you can keep it, but okay, well, node list dot add node DTO, and we return the node DTO. So here what we have val index equal node DTO dot or node list dot in first index, sorry, index of first dot id equal node DTO dot id, and we'll change it with index equal node DTO. And of course not having this one will return an exception, and we will catch the exceptions in the repository. So yeah, but these methods are going to return exceptions on failure. Let's move this to private, and let's have this. Okay, let's keep it not nullable. And node list dot first dot id equal id, and here we return the node list, and here we are going to have note list dot remove. Okay, we need an ID here. And let's say remove all. Okay, we don't need this, but yeah, let's use it because it's simpler. Equal ID. Okay, of course we don't need this result. And let's change it in the repository as well. We forgot to add an ID here for the node that we need to delete. Okay, so let's change it here as well. So yeah, so now we have our local data source ready with this fake data in memory, list of nodes. We are adding the node on the insert, updating, getting. We can get rid of these suspend functions, but in a real like in real life, you will need this suspend, of course, because we will use the SQL Delete needs suspend functions, ktor, whatever. So, but yeah, we can just have simple functions here, or we can have oops. So yeah, we can just have simple functions here, but we can as well keep the suspend to mimic the real situations. Okay, so here we have this local data source. We are going to define this local data source here. So let's say local and local data source. And now in this insert here, what you are going to do is you are going to do equal try and catch exception. Of course, you can catch some custom exceptions, depends on the case, but yeah, I'll just making things simple here. And val result or GTO equal local dot insert node model. So let's make this private. So here we have this DTO, and here of course we will return a result dot failure with the exception, and here result dot success. We have something missing here, which is the mapper. So we need to map this DTO to model. So fun to model, which is going to return node model, ID equal ID, title equal title, and description equal description. And we need to add as well a factory method here. So from model, and let's add the model here, node model, and equal node DTO, and the same here. So here, so we can create a node model from a node DTO, and the opposite, and we create a node DTO from a node model. Of course, we need to add them both in the data layer because the domain doesn't supposed to have access to the data layer. So the domain doesn't know anything about the DTO. The model doesn't know anything about the DTO. So we need to handle everything here in the DTO or anywhere inside this data package here. So we can now have DTO to model, and we map it to a model. So we have this of course here here as well. I will have the node DTO dot from model, and here as well. So we can have an extension function for this as well, but yeah. So for this try and catch, we have something called run catching, which make it easier for us. So with run catching, we can remove all of this code and have the same result. So I can have insert and then to model, and yeah, that's it. So it's going to return the result of this lambda here, and the inner implementation is just success in the success and failure if we have any exception. So yeah, Okay, so now that's it for the insert. So we are going to repeat the same thing for the update and the other operations. So we'll have update here, and we'll have get by ID. We'll pass the ID there, and we will have get all. So it's basically the same. Get all, of course. Of course, here we will have a list, so we need to map it to model. And here in the delete, so we just need a delete and to pass the ID. As simple as that. So now we have our repository is ready, and with this local data source, and now our data layer is basically ready, and we can go to our dependency injection here, and we can pass the node repository implementation, which needs a local data source. We can inject the local data source as well, so node local data source. Well, I prefer to keep this private in the data layer, so let's let's keep it there. I don't need to inject this, but yeah, it depends. So we have this here, and it should be working fine now. And this is our domain layer, this is our data layer. We have the local data source and the DTO and the repository implementation. So if you go here, that's our data layer, that's how it should look like, and it's done. So now we have so now we can check, go to the domain, we are not importing anything here. The repository, of course, the same. If we go to the local, we are not using anything here, we're just using the domain. We are not using the UI, or for example just the domain or the data itself. Same in the UI, we are just using the domain. Of course, if you are not working with different modules, if the data and the domain and the UI are not like separate modules, you can't make sure of that. But there is something called consist, a library that supports Kotlin multi-platform, called consist, or I guess you can add it to the desktop target, I guess, or something like that. But yeah, it's going to work with you with the multi-platform project, and you can add some tests for the architecture or for your clean architecture. So give it a try. It's really amazing. And yeah, so let's make summary now and see what we have here. So we have our domain, our core of the application with the model, with this node model and the node repository. And if you see, like, everything is called node repository implementation, node data source, node DTO. Even this, like, it's a mistake, it should be node local data source. Here, of course, add node screen and whatever. And yeah, so everything is a node actually, because the feature is node. So here, when you are looking or on something related to nodes, of course we'll open this feature, and let's say if you have profile, we will have another feature for profile, or for task, or for category, or whatever. So this makes the project more clean and more readable and extendable, so you can add features in parallel, so you don't need to modify or existing code, just create new features and start again, which make it really easier. So let's finish now our beautiful application, so we can run it and see what we have. So our home screen needs a view model, of course. Let's add a home view model here. Okay, so it's going to be a screen model as well, and we'll have a home state, So this is our home state data class, of course, and we'll have node list, a list of node model, and is loading, is failure, okay, so we don't need is success in this case, because are just, if it's not loading or failure, are just going to show the nodes. And here let's have our states. So private val state equal mutable state flow, and val state equal underscore state as state flow. So here we don't have events, actually we only have a get all. So let's have get all nodes method here, and if state dot value dot is loading, are going to return, otherwise we'll update it. And we'll make it loading. We need here private val node repository. Okay, so let's open our coroutine scope now, launch, and we'll have get all is on success. Are going to set our nodes here. So we will make the loading set to false, and nodes. So I can have them here from the on success lambda. And okay, so here I think that I need to reset it, because it can be failure as well. So let's just reset it here, and let's add the on failure lambda, and instead of setting the nodes, we'll set the on failure to true. Okay, so this looks good. Let's define. Okay, so now I will need the init and get all nodes in the init. When we initialize this view model, let's go to the screen and let's state view model, or remember screen model, and let's just define it. So we have node module. Again, you are going to use something like coil here, so we don't need this, but I'm just trying to make something similar, so doesn't look too different from real cases. So for the state here, we will have a state equal view, or by view model dot state dot collect as state. We can have equal here, but we just need to type value. So type state dot value. I'm just adding by to get to access to the getter directly. So here I'm just going to add a lazy column with a modifier filling max size and padding values of something like 20 dp, and I'll have some list items, material 3 list item, so containing just the text. Of course I need to have items, and I'll pass the list of nodes here. So nodes, for each node we will have this list item, let's move this. So here we'll have node title and let's add a key as well. So key equal it.id. So yeah, just simple lists here to have the nodes. I'm not going to add the edit node, feel free to add it. So here I need to add the navigate back button to the add node screen. So let's add it here, val navigator, and I'll add a navigation or the up bar, top bar. Oh, oops. So, and an icon button, maybe on click we'll have pop, and let's add an icon here, so rounded, maybe arrow back, and oh, forgot about the icon, composable. So yeah, that's navigate back. Okay, let's refactor this. Let's opt in, and I think that the title is missing. Title add note. So yeah, this looks good. Okay, this is good. So let's run our application and see what we have. Oh, okay, so what we have here. Okay, so we need to have the coroutines core for Compose for Android. So here is complaining about coroutines and the main dispatcher and so on. So let's add coroutines here. I'll add 1.8.0 RC2, and let's add coroutines core and coroutines Android. Okay, I hope that this is enough. So we need to add coroutines core and coroutines Android here. Let's sync the project and see. Oh, I still have this coroutines error. I'm going to add coroutines swing as well, so we can use the main dispatcher, but I'm not sure why this is happening. But yeah, let's add coroutines core and coroutines swing for desktop and coroutines Android for Android, and try again. Okay, here we go. So we have this notes. Okay, so let's fix this. So we can add a node here. I think that we need to clear the and clear this after adding a node and navigating back and refreshing the list here. So let's do this. Okay, so we need to use the padding values. Let's pass a modifier here. And add this modifier dot padding, which is the padding values. Let's do it for the home screen as well. So padding 8. So yeah, that's it. So here, in order to first for the add node screen, we can navigate back on success. So we can add launch the effect if state is success. We can navigate back, and in the home we can have a launched effect as well. So units, whenever we open this screen for the first time, we need to let's call on event. Okay, we don't have events. Let's add an event, home event, and sealed interface, that object, refresh notes, and home event. Let's add an on event here, so private fun or fun on event, home event, and when event is refresh nodes, so we'll just get all nodes. And yeah, that's it. So we will call it here. So for the first time, on event, home event dot refresh nodes, and I think we can delete this now, and let's try again. So this is our application. Let's add a new node, hi all, and add node, and here we go. We have the nodes. Okay, wow, what's going on here? Okay, the keys, we didn't handle the keys. So so how I'm going to do it for now is to whenever I add a new item, I'll make the ID equal to the node list dot size or to string. So it's going to be something like auto increment IDs. So the size is 0, it's going to be 0, 1, 2, something like that. So let's try again, and we have here our nodes, and we can add, and yeah, it's working fine. And that's it for this tutorial for using clean architecture with Compose multi-platform projects and Kotlin multi-platform projects. See you next time.